In this class, we're going to go over a question on simple linear regression. Okay, let's consider the question on the screen. Suppose you have collected data on vegetable yield in kilograms and the quantity of fertilizer used in kilogram for a set of 10 different plots. The data is as follows, okay? We have fertilizer and we have yield and their respected value. You understand? Okay, we are asked to calculate the simple linear regression function. Y is a function of x. And then we are asked to predict the value of y when x is 4.5. Then question C says we should calculate the arc squared and interpret the answer. Okay, now please, I want you to pay attention. You see, in solving this question, okay, let's start with the first question. We are asked to find simple linear regression function y equals to fx. Do you know that a typical regression equation looks like this? Y equals to b naught plus bix. You understand? If you are part of our previous class on simple linear regression, you are going to understand what I mean by that equation. That is, the predicted value of y is equals to b naught plus bix, where b naught is the intercept, you understand, and bi is the gradient or slope, you understand. Just pay attention, you're going to understand, okay? Just pay attention. You see, this is how the equation that we are asked to derive, this is how it is going to look like. This equation is also the same thing as y is a function of x, you understand. That is, any changes in x will lead to a change in y, you understand, where x is the independent variable and y is the dependent variable, you understand, because x is the independent variable because x does not depend on y, it is y that depends on x. You can see y is equals to fx. If there is any change in x, there will be a corresponding change in y, you understand. So this is how the regression equation that we are asked to derive will look like. On this equation we have y, this y arc is the predicted value of y, and b naught is the intercept, bi is the slope, and x are the values of x. I'm going to teach you how to use this equation, okay? Now, we cannot derive the simple linear regression equation without knowing all these values, you understand? Without knowing b naught and bi, you understand? Don't forget I told you b naught is the intercept, you understand, and bi is the gradient. So we cannot know the simple linear regression equation without knowing the value of intercept and the gradient. So that leads us to constructing a table, you understand. Don't worry, if you came across this question in exam, let me teach you. The first step is that you have to remember your formula, okay? You have to remember your formula. Having known that this is how the regression equation is going to look like, you have to remember the formula. Let's start by let me give you the formula for b naught, which is the intercept. B naught is calculated by taking the mean value of y. Please pay attention. B naught is equals to mean value of y minus bi multiplied by the mean value of x. You understand? By using this formula, you are going to get the value of your b naught. Are you paying attention? Now, we cannot even know the value of b naught, which is the intercept, without knowing the gradient, you understand, because intercept is equals to the mean value, you understand, the mean value of y minus the gradient multiplied by the mean value of x. So we still need to know the formula for calculating the gradient. To get the gradient, you just have to make use of this formula. Gradient is equals to, put this in brackets, summation x minus x bar multiplied by y minus y bar all over summation x minus x bar squared, you understand. By using this formula, you're going to get the bi, which is the gradient, you understand. Please pay attention, okay? You are going to understand. It's simple, okay? See, the reason why I'm giving you this formula is because this formula will tell us what you're going to have on our table, you understand. See, this formula that you have here will tell us what we are going to have on our table. You know, when I start this class, we start with the first question, and I told you that this is how the regression equation will look like. Now, having known how the regression equation will look like, we need the value of b naught, which is the intercept, and we need the value of bi, which is the gradient. Now, to get the gradient, I gave you this formula. To get the intercept, this is the formula that we're going to use. Now, so having known the formula, we can now proceed to prepare the table, okay? So I'm going to prepare my table now. So I have prepared my table, you understand? This is the table that I prepared. You see, on this table, I have y. Y are the values of y that were given in the question. You understand? Listen. Y that you see here are those values of y that were given in the question. And the first value that were given is 9. You understand? So I'm going to have here 9. Here we comprise 12. I'm going to have 6, 10, 9, 10, 7, 8, 12, and 6. You understand? So I've already put the values of y. Now, look at the values of x that were given in the question. We are given 6.9. Okay? We are given 7.6. Okay? We are given 5.2. Okay? 5.6. 5.7. Then 7.7. Okay? We are given 5.8. Do you understand? We are given 5.5. Then we are given 6.7, and the last value of x is 5.3. Okay? Now, please, I want to pay attention. See, the goals is to determine the value of the gradient. You understand? If I know the gradient, I can proceed to get the value of the intercept. You understand? Okay? So let's start with the gradient. With respect to this gradient formula, I'm going to have some values on this table. Okay? And the first that I'm going to have is x minus x bar. You understand? Okay, so I'm going to create another column for x minus x bar. So I'm going to have x minus x bar, where x bar is the main value of x. You understand? The main of the x that we have on this table will give us the value of x bar. You understand? And main x bar is equals to summation x all over n. You understand? That is, we are going to sum all the value of x that we have and then divide it by the total numbers of x. You understand? So let's start. For this, I'm going to have 6.9 plus 7.6 plus 5.2 plus 5.6 plus 5.7 plus, this is 0.2, it is not negative, it is not minus, okay? It is 5.7 plus 7.7 plus 5.8 plus 5.5 plus 6.7 plus 5.3. The summation, please pay attention. The summation is 62. You understand? The summation of all the x, that we have is 62. So I'm going to have here 62. You understand? Okay. Now we can now proceed. X bar is equals to summation x. Summation x is 62. 62 all over n. N is the total numbers of x. So I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You understand? So we are having 10. I'm going to have 10. So 62 divided by 10 is 6.2. So the main value is 6.2. You understand? So just keep it. Write it somewhere. The x bar is 6.2. X bar. Okay, let me write it here. X bar is 6.2. X bar is 6.2. You understand? Okay. So let us proceed with the question. Now, so let's determine the values of these cells now. For these cells, I'm going to have individual values of x. Are you paying attention? The difference between the individual values of x and the x bar, which is main value, will give us the value of these cells. You understand? Please pay attention, okay? See, x minus x bar. Even let me put a symbol here to signify that we don't have only one x. We are having how many x? We are having 10x. You understand? So xi signify that we don't have only one values of x. You understand? So if I want to get the value of these cells, I'm going to take the difference between the x that I have and the main value of x. So if I want to get the value of these cells, that will be 6.9, which is x, the corresponding x for these cells. 6.9 minus 6.2. Do you understand? Listen to the explanation again. You see, what I want to determine now is that I want to get the value of all these cells. You understand? I want to get the value of this column, okay? And the column says the difference between x and x bar. Are you paying attention? I've already gotten the value of my x bar as 6.2. So if I want to get the value of these cells, I'm going to take the corresponding x of that cells minus the main value of x. You understand? So here I'm going to have 6.9 minus 6.2. That will be 0.7. You understand? Okay, 0.7. So the value here will be 0.7. Okay, 7.6 minus 6.2. That will be 1.4. 5.2 minus 6.2. That will be negative 1. Okay, 5.6 minus 6.2. That will be minus 0.6, you understand? Minus 0.6. 5.7 minus 6.2. 5.7 minus, that is minus 0.5. Okay, 7.7 minus 6.2, that will be 1.5. Okay, 5.8 minus 6.2. 5.8 minus 6.2, that will be minus 0.4. Minus 0.4. Then 5.5 minus 6.2, that will give us minus 0.7. Then 6.7 minus 6.2, that is 0.5. 5.3 minus 6.2, that will give us negative 0.9. Negative 0.9. Okay, so these are the values of the difference between the individual x, and the main value of x. These are the values that I got. Okay, now let's go back to the gradient formula. You understand? The formula of gradient, we still need the difference between the y value and the mean value of y. You understand? See, let me put this. This signifies that we are not only having a single value of x, there are many x. For example, we are having 10 values of x on this table. Is that not it? So let me put this y as well. The meaning of this I is that we are not only having a single y. As you can see, we are having like 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We are having 10 values of y. Okay, so it's necessary that I put it like that, and this as well. Now, on the next column will now be for the difference between the y values that we have and the mean value. You understand? So I'm going to have on this table y minus, y minus the mean of y. Y minus the mean of y. Okay, you can see now. So this will be for the next column. Now, for this I'm going to have y. If I want to get the value of these cells, I have to subtract y, this is 9, minus the mean value of y. But I haven't gotten the mean value of y, so I have to calculate the mean value of y. The mean value of y is equals to summation y all over n, you understand? So I'm going to have the mean value of y is summation y is what? Sum of all these numbers together. That is 9 plus 12 plus 6 plus 10 plus 9 plus 10 plus 7 plus 8 plus 12 plus 6. That will be 89, okay? So here I'm going to have 89 as the summation. So, you know, this sign symbolizes summation, you understand? The sign that you see here symbolizes summation. So I add all these values together, I have 89. So n is the total numbers of y that we have, and we've been given in the equation that they are 10. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So here I'm going to have this divided by 10. So the main value of y is 8.9. Okay? That will be the main value of y. So let us write it here. The mean value of y is 8.9. 8.9. Okay? So let me erase this. Trust you get what I'm doing. If you didn't understand, kindly reverse the video and listen to the explanation again. Okay? So now we can easily get the value of these cells now. Okay? Because we've already gotten our mean value of y. So let's start with the first cells. Okay? For this, I'm going to have y minus the mean value of y. What is the corresponding y of these cells? You are going to trace it to the value of y. That is 9. So I'm going to have 9 minus 8.9. That is what? 0.1. Okay? 0.1. For this, the corresponding value of y is what? Is 12. So I'm going to have 12 minus 8.9. 12 minus 8.9 is 3.1. So that will be 6 minus 8.9. That is negative 2.9. For this, I'm going to have 10 minus 8.9. That is 1.1. Okay? Yeah, 9 minus 8.9. That is what? 0.1. Okay? 10 minus 8.9. That will be negative. No, 1.1. Sorry, 1.1. Please, do you understand what I'm doing at all? See, the formula will tell you what you're going to have on this code on this table. So I got the mean of y, and then I started subtracting the corresponding value of y from the mean of y to get the value of each cells. You understand? So for this cell, the corresponding value of y is 7. 7 minus 8.9, that will give us negative 0.4. Negative 0.4. Here, 8 minus 8.9, that is what? Negative 0.9. Negative 0.9. Here, 12 minus 8.9, that will give us, that is 3.1. 3.1. For this, 6 minus 8.9. 6 minus 8.9, that will give us negative 0.9. Now, let me write this very well. Okay, so now, we've gotten the difference between the values of y and the mean value of y. Now, let's go back to the formula. From this formula as well, we need to take the product, you understand? Because look at the formula. The gradient is equals to summation of the product of this bracket and this bracket, you understand? So we are still at the numerator, okay? We are still at the numerator, you understand? So we still need to take the product of this bracket and this bracket. Do you understand? That is, we need to take the product of this and this. So on this column, on this table, I'm going to have x minus x bar multiplied by y minus y bar, you understand? So just listen, okay? Let us put I. Now, let us start with the first column. For the first column, we're going to have this multiplied by this, you understand? X minus x bar for this is what? 0.7. And y minus y bar is what? 0.1. So I'm going to have 0.7 multiplied by 0.1. That will give us 0.07. 0.07, okay? Now, for the next cells, 1.4 multiplied by 3.1, that will be 4.34. 4.34. For these cells, negative 1 multiplied by negative 2.9, that is 2.9. Negative 0.6 multiplied by 1.1, that is negative 0.66. Do you understand? I'm just taking the product of this and this to get all the values here, you understand? Take the product of this and this, you get all the values here, because according to the gradient formula, we just have to take the product of this and this, x minus x bar and y minus y bar, you understand? So that's what I'm doing. For this cell, I'm going to have negative 0.5 minus, negative 0.5 times 0.1, that is negative 0.05. For this, 1.5 multiplied by 1.1, that is 1.65. For this, negative 0.4 multiplied by negative 0.4, that is 0. Sorry, please pay attention. I think something is wrong here. I want to check something, okay? I think there is a mistake while solving this question. See, for these cells, y minus y bar will be 5.8, okay, 7. 7 minus 8.9. What will be the answer? I want to check. 7 minus 8.9. 7 minus 8.9 is negative 1.9. Negative 1.9. So this will be negative 1.9. You understand? Please pay attention. I discovered that there is a mistake while I'm taking the deviation, or when I'm taking the difference between the values of y and the mean value of y. So I noticed that, so I changed it, okay? I corrected it. Do you understand? So if you subtract 8.9 from 7, this is what you're going to have, negative 1.9. Do you understand? Okay, so let us proceed. Now, for this, I'm going to have negative 0.4 multiplied by negative 1.9. Negative 0.4 multiplied by negative 1.9, that is 0.76. 0.76. So here I'm going to have negative 0.4 multiplied by negative 0.9. What's happening? Please, kindly pay attention. I think the values here is not correct, okay? Please just, I'm sorry, I think it is why I'm rushing, that's why I think I made a mistake. See, let us get the value of these cells. The value of these cells will be 5.5, which is the value of x, minus 6.2. 5.5 minus 6.2, that will be negative 0.7. So this will be negative 0.7, okay? So I'm sorry, okay, I made a mistake. And while taking the difference between the values of x and the mean value, okay, sorry, okay. Now let us proceed. I think we need to be careful now. Even the value of these cells is, okay, let's proceed. This is negative 0.7 multiplied by negative 0.9. Negative 0.7 multiplied by negative 0.9, that is 0.63. So here I'm going to have 0.63. For this, 0.5 multiplied by 3.1, that is 1.55. And for this, negative 0.9, I think there is another mistake here. This should be y minus y, mean value of y. 6 minus 8.9, that should give us negative 2.9. Negative 2.9. Okay. Make use of a calculator, okay? When you are, maybe if you are permitted to use a calculator, make use of it in the exam, okay? So that you won't have error. Do you understand? Okay, so now for the value of these cells, I'm going to have negative 0.9 multiplied by negative 2.9. That will be 2.61. 2.61. Okay, so we have gotten all these values. I just want to check if there is any need for correction. Okay, I just want to check if there is any need for correction. There is no need. I think we are good to go. Now let us proceed. See, so we are done with the numerator. Okay, now let's proceed to the denominator. The denominator says x minus x bar squared. You understand? That is, we should square the difference between the values of our x that we have and the mean value of x. You understand? Okay, the values of x, the difference between the values of x and the mean value of x are these values. You understand? So I'm going to square all these values to get the numerator. The denominator. Okay, the denominator is x minus x bar squared. So I'm going to have x minus x bar squared. Okay, now for these cells, I'm going to square the corresponding value of x minus x bar squared. You understand? 0.7 squared is what? 0.49. Okay, so I'm going to have 0.49. For these cells, I'm going to trace it to that value of x minus x bar. This is it. It is 1.4. 1.4 squared will be 1.96. So I'm going to have 1.96. Okay, for these cells, I'm going to trace it to x minus x bar. That is negative 1. Negative 1 squared is what? Is 1. Okay, so for these cells, I'm going to trace it to this place, negative 0.6. Negative 0.6 squared is 0.36. For these cells, just trace it to the column of x minus x bar. The corresponding value is what? Is negative 0.5. Negative 0.5 squared is what? That is 0.25. Okay, now for these cells, just trace it to the corresponding value of x minus x bar and square it. 1.5 squared is what? 2.25. Okay, now for these cells, negative 0.4 squared, that is 0.16 rather, 0.16. Now for this, just trace it to the values of x minus x bar. The corresponding value is negative 0.7. Negative 0.7 squared is 0.49. So for these cells, to raise it as well, 0.5, that is 0.25. You will square it. For this, negative 0.9. Negative 0.9 squared is 0.81. Okay, so these are the value of x minus x bar squared. I want you to pay attention. Now go back to the numerator. In this formula, we have summation the values of x minus x bar. This sign means summation, you understand? So I'm going to sum all these values together. Okay, the reason why I'm going to sum all these values together is because according to the gradient formula, we need the summation. You understand? This sign means summation. This sign that you see here means summation. Okay, so let us sum all these values together. 0.07 plus 4.34 plus 2.9 plus negative 0.66 plus negative 0.05 plus 1.65 plus 0.76 plus 0.63 plus 1.55 plus 2.61. What's the answer? That is 13.8. So I'm going to have 13.8 here. Now, if you go back, if you check the formula again, you will discover that we still need the summation of the difference between the x values of x and the mean. You understand? We need the summation of all these values. You understand? The square of the difference between the values of x and the mean value of x. We need their summation because this sign means summation. Okay, so we need to sum all these values together. So here I'm going to have 0.49 plus 1.96 plus 1 plus 0.36 plus 0.25 plus 2.25 plus 0.16 plus 0.16. Okay, plus 0.49 plus 0.25 plus 0.81. That is 8.02. You understand? 8.02. So here I'm going to have 8 0.02. So right now we can determine the gradient, you understand, because we've gotten all we need in the formula. Okay, so gradient will be equals to summation the product of this and this. The summation of the product of this and this bracket is 13.98. So I'm going to have 13.98, oh sorry, 13.8 rather, 13.8 all over the summation of this difference between the square. Okay, the difference of the square between x values and the main value of x is what? 8.02. So the summation is 8.02. So what is the gradient? 13.8 divided by 8.02, that is 1.72. So the gradient is equal to 1.72. Do you understand? Okay, now having gotten the gradient, we can easily get the value of the intercept. You understand? I represented the intercept as b naught. You understand? So the intercept is equals to the mean value of y. The mean value of y is is 8.9. So I'm going to have 8.9 minus the gradient. The gradient is 1.72. So I'm going to have 1.72 multiplied by the mean value of x, which is 6.2. You see, this is the formula for the intercept. Okay, intercept, gradient. You understand? This is the gradient, this is the intercept. So from the intercept formula, I need to take the difference between the product, or between the mean value of y, which is 8.9, and the product of the gradient and the mean value of x. The gradient is 1.72, the mean value of x is 6.2. So the intercept is equal to 8.9 minus 1.72 multiplied by 6.2, that is 10.664. 10.664. Okay, so the intercept is equal to negative 1.764. Negative 1.764. Okay, so we can approximate to do 2 decimal place. Okay, let's approximate to 2 decimal place. So I'm going to have the intercept is equal to negative 1.76. Do you understand? Okay, now we've gotten the intercept and we've gotten the gradient. You understand? So we can easily compute our simple linear regression equation. You understand? Don't forget that from the question we are asked to determine we are asked to find a simple linear regression function y equals to fx. You understand? So we can easily determine the function, because I've already told you when I start this class that this is how the simple linear regression function will look like. You understand? This is how the simple linear regression will look like. You understand? That is, y is a function of x. You understand? So y is equals to b naught plus bi multiplied by x. See, the b naught here is the intercept, and the intercept is what? Negative 1.76. So I'm going to have the, see, this one that you see here means the predicted value of y. You understand? The predicted value of y is equals to b naught, negative 1.76, negative 1.76, are you paying attention, plus bi. Bi is what? 0 on. Bi is gradient, and gradient is what? 1.72. So I'm going to have plus 1.72 multiplied by x. Okay? You understand? So that is the regression equation. That is the regression function that we are asked to determine. Okay, so we are done with the first question. Okay, we are done with the first question. Now let's proceed to the second question, which is question B. We are asked to predict the value of y when x is 4.5. You understand? We are asked to predict the value of y when x is 4.5. See, I'm going to erase this solution. I'm very sure you've written all this. If you have not, quickly write it. I want to erase this. So we've gotten our let me write it here. Okay, let us write it here. The b naught, which is the intercept, is negative 1.76. Okay, I don't want to use the approximated value. You understand? You know, I approximate it to negative 1.76, but the value actually is what? Negative 1.764. So if you want to approximate it, you can put it there now that it is now approximated to negative. I'm just looking at a way to write this. Okay, let's erase this as well. So the gradient is what? 1.72, you understand? So the B naught can be approximated as negative 1.76, okay? So it is necessary that you put the values, then you cannot put the sign that it has been approximated to 2 decimal places, you understand? So it is very important that you put it like that, okay? Now, so I can erase this now, and as well I can erase this. So the regression equation, you have to keep this, okay? You have to keep this regression function, this simple linear regression function. This is the regression function that we are asked to determine, and we are already done with that. So you have to keep it because you are still going to use it to compute some values that you are asked to calculate. You know, don't forget we are asked to calculate arc square. You understand? So just pay attention. Now let's proceed to question B. We are asked to determine the value of y when the x is 4.5. To get the value of y, we have to determine y when x is what? 4.5. Plus, we are now going to make use of our regression equation. You understand? We are going to make use of our regression equation. The regression equation is what? The predicted value of y is equal to negative 1.76 plus 1.72. Okay, 1.72 multiplied by. Please, I want to just check something here. The regression equation, okay, is negative 1.76. Let's put 4. Negative 1.764. Okay, put 4. I don't want to use the approximated value, you understand? So I make use of all the values that we have as our B naught, you understand, which is the intercept. That is negative 1.764, okay? Negative 1.764 plus 1.72 multiplied by x. Now, the value of x we now replace with 4.5, you understand? Because we are asked to get the value of y when x is 4.5. So instead of x, I'm going to replace it as 4.5, okay? So that will be 4.5, okay? So the value of y will now be negative 1.764 plus 1.72 multiplied by 4.5. That is 7.74. 7.74, okay? So the predicted value of y will be negative 1.764 plus 7.4 plus 7.74 rather. That is 5.976. 5.976. So you can approximate to 2 decimal places. That is 5.98. Okay. So the value of y when x is 4.5 is 5.98. You understand? Okay, to 2 decimal places. Now, so we are done with the second question. You understand? So let us proceed to the third question. The third question says we should determine the arc squared and interpret our answer. Now, please, I want you to pay attention. To get the arc square simply means the coefficient of determination. You understand? I'm going to explain. See, if you missed our first class and the second class, please kindly check the description of this video. You are going to see some link there. Click on that link to watch those classes. You understand? Now, to get the r square is given by this formula. R square is given by this formula. Okay, let me erase this. Now, let us keep this because we've gotten the regression equation. That will be negative 1.764. Then we have 1.72. You understand? Okay, so I can erase this now. Now, r squared is given by this formula: SSR all over SST. You understand? Don't worry, I'm going to explain, okay? Just pay attention. SSR refers to the sum of square due to regression. You understand? SSR is the sum of square due to regression, and SST is the sum of square total, or total sum of square. Okay, now to get the SSR and SST, I'm going to give you some formula, and I want you to pay attention. To get the SSR, you have to use this formula. The SSR is equals to summation of the predicted value of y minus the mean value of y squared. This is the formula that you're going to use to get the SSR. Listen again. To get the SSR, this is the formula that you're going to use to get the SSR. SSR simply means sum of square due to regression. Now, SST is another formula that you need in an attempt to compute your coefficient of determination. SST can be gotten using the formula summation of y minus y squared. You understand? I'm going to explain, okay? Just pay attention. You see, do you know, listen, please kindly listen. This is the predicted value of y. This y is the mean value of y. You can see bar. You can see bar at the top. That is the mean value. Now for SST we have yi. That is the difference between the individual y and the mean value of y squared. The summation will give us the SST. Do you understand? Now, by these two formula, you can compute the coefficient of determination, okay? And there is another thing that is called sum of square due to error. I explained that in our previous class, so there is no need to go to that. But with respect to all we have here, we can easily compute the coefficient of determination. So let us start by determining the value of our SSR. You understand? Okay. Please, I want you to pay attention. So we are going to need another table. So I'm going to erase this table now to prepare another table to compute the coefficient of determination, which is R squared. Okay, kindly follow me. So this is the table that I'm going to use to calculate the my coefficient of determination. You understand? Now, I told you that in our previous class we learned that the coefficient of determination measures the it measures the degree of variability in our dependent variable that can be explained by the independent variable. You understand? Please listen to the explanation again. It measures the variability, that is the changes in our dependent variable that can be explained by our independent variable. In this case, the dependent variable is the yield, you understand? And the independent variable is the fertilizer, which we represent as X. Do you understand? But I want you to pay attention. You know that ordinarily, when you increase the fertilizer that you apply on your crop, the yield should increase. Hope you know that. But there are some cases, even in this, you know, when the fertilizer that we apply is 6.9, we have 9 yield, 7.6 we have 12, 5.2 we have 6, 5.6 we have 10. You can see that increase in fertilizer should lead to a corresponding increase in yield. But there are some cases, even in this figure, that though we increase the fertilizer, the yield doesn't really increase to that extent. And the reason is because there are some factors of production. For example, let's say you want to produce a maize crop. Are you paying attention? And you know, you cannot only you don't only need fertilizer. There are some things that you combine together. For example, land. Are you paying attention? So let's say that farmer is cultivating on a single plot of land. There will be a time that the land will be old. You understand? It won't be able to produce enough because you have already used it up. You understand what I'm saying? That is the law of diminishing return in economics. I don't want to delve into that aspect, but I just want to explain the variability. You understand? The variability might be due to many things. You understand? First, the variability might be increase in our dependent variable. As you can see, when the dependent variable increase from 6.9 to 7.6, increase in our independent variable. As you can see, when the independent variable, which is the fertilizer, increase from 6.9 to 7.6, you can see the corresponding change from 9 to what? To 12. You understand? The yield also increased from 9 to 12. Are you paying attention? But there are some times when if you increase the independent variable, there will be a little or no increase in the dependent variable. The reason is because some other factors might also set in. You understand? That is what I explained just now, okay? So now, how do we calculate the R squared? You understand? How do we calculate the R squared? R squared is given by this formula, SSR all over SST, as already stated before. This is the formula for SSR, which is the sum of square due to regression. See, this formula is predicted value of y minus the mean value of y squared. You understand? Their summation will give us the sum of square due to regression. Okay, so on this table, I'm going to have the following. The formula is going to tell me what I'm going to have on the table. Okay, that is why I prefer when you come across question. Okay, first remember your formula. If it's a question that involves you presenting a table, first remember your formula. The formula will tell you what you are going to have on your table. Okay, so here I'm going to have the predicted value of y. You understand? The predicted value of y. Then from here I'm going to have the difference between the predicted value of y minus the mean value of y, because according to the formula for sum of square due to regression, I need to take the difference between the predicted value of y and the mean value of y and square it, then sum it together to get the sum of square due to regression. And don't forget that the predicted the mean value of y is what? 8.9. You understand? The mean value of y that we calculate is what? 8.9. Okay, now so let's start with the predicted value of y. Just pay attention. Okay, I'm going to explain it step by step. To get the predicted value of y, all you have to do is that you just have to plug in the corresponding value of x into the regression function that we got. You understand? Don't forget that the regression function that we got is what? The predicted value of y, which is y arc. You understand? This arc signifies predicted value of y. Okay, is equals to negative 1.764 plus 1.72 multiplied by x. See, now I want to get the value of these cells. You understand? Which is the predicted value of y. I'm going to have the predicted value of y is equals to, for the first cells now, are you paying attention? Negative 1.764 plus 1.72 multiplied by x. Now, the corresponding value of x for these cells is what? 6.9. So I'm going to have multiplied by 6.9. Okay? So the predicted value of y will be equals to negative 1.764 plus 1.72 multiplied by 6.9. That is 11.868. 11.868. You understand? So the predicted value of y is equals to this negative 1.764 plus 11.868. That is 10.104. 10.104. So the predicted value of y is 10.104. So here will be 10.104. Do you understand? Okay, let's proceed to the second one. To get the value of these cells now, I'm going to have the predicted value of y is equals to negative 1.764 plus 1.72 multiplied by what is the corresponding value of x for these cells? That is what? 7.6. So we are going to substitute 7.6. Okay, so the predicted value of y is equals to negative 1.764 plus 1.72 multiplied by 7.6. That is 11.308. 11.308. Okay, 11.3. Oh, sorry, I did something else. That is 13.072. 13.072. So the predicted value of y is equals to negative 1.764 plus 13.072. That is 11.308. 11.308. Okay, so here I'm going to have 11.308. You understand? Okay, to get the value of the next cells, all you have to do is just substitute the value of x as 5.2. You understand? So here I'm going to have something like, for the third one, I'm going to have the predicted value of y is equals to negative 1.764 plus 1.72 multiplied by 5.2 now, because I want to get the value of these cells. The corresponding value of x that is corresponding to these cells is what? 5.2. So I'm going to have 5.2 here. So you calculate, you're going to get something like, let me just check. That will be 7.18. 7.18. Okay. For the next one, you're going to have 7.868. 7.868. 8.04. Then 11.48. Then 8.212. Then 7.696. here 9.76, 7.352. You understand? Okay, so those are the predicted value of y. If you approach it with respect to what I taught you, you are going to get all these values, and if you get all these values, that means that you are correct. Okay, now the next column is the difference between the predicted value of y and the mean value of y. Don't forget that the mean value of y is what? 8.9. You understand? So I'm going to be taking each of these values and be subtracting 8.9 from them. You understand? So 10.104 minus 8.9, that is 1.204. 1.204. 11.308 minus 8.9, that is 2.408. 2.408. Now for the next cell, 7.18 minus 8.9, that is negative 1.72. So 7.868 minus 8.9, that is negative 1.032. 8.04 minus 8.9, that is negative 0.86. And for this, 11.48 minus 8.9, that is 2.58. 8.212 minus 8.9, that is negative 0.688. And this 7.696 minus 8.9, that is negative 1.204. And for these cells, I'm going to have that is 0.86. Then for this, I'm going to have negative 1.5848. Do you understand? Okay. Now you can see that for the next step, we still have to square it. You understand? See, you still have to square, because according to SSR, that is sum of square due to regression, we need the difference of the square. You understand? Okay, the square of the difference between the predicted value of y and the mean value of y, the summation will give us the sum of square due to regression. You understand? So we still need to square the differences. So having taken the differences now, we still need to square them. So the next column will be predicted value of y minus the mean value of y squared. Okay, so let's square all these values. 1.204 squared, that is 1.449. Okay, 2.408 squared, that is 5.798. Okay, and negative 1.72 squared is 2.958. Okay, so for this we are going to have 1.065. Square this, we are going to have 0.739. If you square 2.58, we are going to have 6.656. And for this, negative 0.688 squared, that is 0.473. Negative 1.204 squared, that is 1.449. And 0.86 squared, that is 0.7396. Now the next one, negative 1.548 squared, that is 2.396. 2.396. Okay, so having squared all these values, I got these values. Now the summation of these values will give us the sum of square due to regression. Okay, so let us sum all of them together. If you sum 1.449 and so, if you sum it up together, all these values, if you sum them together, you're going to have 23.7226. 23.7226. Okay, so that is the sum of square due to regression, SSR. Let me just replace it with the formula. Okay, see, pay attention, make sure you master this formula. Okay, see, remembering the formula alone have solved 50% of the problem. You understand? So make sure you master this two formula. So the sum of square due to regression now is 23.7226. 23.7226. That is the sum of square due to regression. Now let us calculate the sum of square due to total. Now to get the sum of square due to total, all you have to do is that, I'm very sure you are done with this, so I can erase it. To get the sum of square due to total, we also need to make use of the formula. the sum of square due to total is equals to the summation. You understand? This sign means summation. The summation of the difference, the summation of the square between the difference between the individual y values and the mean value. That will give us the sum of square due to total. You understand? So let us take it step by step. We are going to have y minus the mean value of y minus the mean value of y. You understand? Okay, so don't forget that we have already prepared on our first table while we are calculating the simple linear regression equation. We have already done y minus y, the mean value of y. So you can easily go to that table and then just put all the values there. We have 0.1 for the first one, and you can, if you want to punch a calculator, you can also do that. But you know, in exam is against time. You understand? Exam is your test against time. Even if you know it, you must be able to tell, you must be able to write what you know within the time frame that you are given in exam. You understand? So since you have already done it on the first table, just put all the values there. So here I'm going to have 0.1, 3.1, negative 2.9, 1.1, 0.1, 1.1, yes, negative 1.9, so negative 0.9, 3.1, negative 2.9. okay? So these are the values of the difference between the values of y and the mean value of y. You understand? Okay, so now the next step is that just go back to the formula. You understand? From the formula we still need the square. You understand? Because you can see y minus y bar squared. You understand? So we still need to square the difference. So I'm going to square all these values. Now I want you to pay attention. For the next column I'm going to have y minus y bar squared. That is 0.1 squared will give us 0.01. 3.1 squared will give us 9.61. Negative 2.9 squared will give us 8.41. 1.1 squared will give us 1.21. 0.1 squared will give us 0.01. 1.1 squared will give us 1.21. Negative 1.9 squared will give us 3.61. You understand? 3.61. Negative 0.9 squared will give us 0.81. This is 0.81. 3.1 squared will give us 9.61. The negative 2.9 squared will give us 8.41. You understand? Okay. Now, if you check the formula again, we still need the summation. So I'm going to sum up all these values. You understand? So 0.01 plus 9.61 plus 8.41 plus 1.21 plus 0.01 plus 1.21 plus 3.61 plus 0.81 plus 9.61 plus this, which is the 8.41. If you sum all these together, you're going to have 42.9. 42.9. So that is the total sum of squares. The SST now is 42.9. okay, the SST is 42.9. so here I'm going to have 42.90. okay, so now we have gotten the sum of square due to regression and the total sum of square. We can easily determine the coefficient of determination. You understand? The coefficient of determination is r squared. R squared is equals to SSR all over SST. And SSR is equals to what? 23.7226. And SSR is 23.7226. okay, and SST is 42.90. okay, so R squared is equals to 23.7226 divided by 42.90. That will give us 0.5529. You understand? So I'm going to have 0.5529. So that is the coefficient of determination. See, the coefficient of determination now in percentage, you understand, is equals to 0.5529 multiplied by 100. okay, so R squared is equals to 55.29%. you understand? So that is the coefficient of determination, 55.29%. Now don't forget that in the question we are asked to interpret our answer. You understand? We are asked to interpret our answer. Now, how do you interpret? Don't forget the function of coefficient of determination. The coefficient of determination is to tell us the degree of variability in our dependent variable that can be explained by our independent variable. Now, to interpret this question, since we are dealing with fertilizer and yield, how does fertilizer affect yield? That one is determined by coefficient of determination. Now, having gotten our coefficient of determination as 55.29%, now you cannot put your interpretation like this. Since the coefficient of determination is 55.29%, this implies that the 55.29% of variability in yield can be explained by the fertilizer applied. You understand? So that is the solution to that question. In some questions, you might be asked to determine the coefficient of correlation. You understand? That one, if you want to learn about coefficient of correlation, check the link in the description of this video. Watch that class, that first and second class. Watch it. I explain in details. You understand? So that will be all for this class. If you have any question, let me know in the comment section. Okay? And before you go, don't forget to like and share the video, and tell me what you've learned in this video in the comment section. Okay? See you in the next class.